Hello and welcome back. Okay, in the last audio video we built a new driver controller in order to interface the channel boards we've made before. And that's all sat on breadboard at the moment. And really and truly the last thing that we have to do now is turn that into a PCB so it can be the final circuit, hopefully. So let's have a bit of a refresher about what the controller circuit is doing, and then we'll start taking a look at the design and schematic for that. Right, I've got the CPU out and I've only got the UART connected at the moment. And here is the audio circuit as we've been working on it. Now the PCBs are pretty much final for the channels. I'm not expecting to iterate them at all. And we built the new control circuit in the last video, and that's what I would like to convert to PCB and then just kind of call this thing done as long as it works. Fortunately, I've borrowed some of the cables from here. Now, bus connection, that's easy. I had to double check my code, but it's device 9 we've got here, and on the left is the power, so that goes in like that. I actually borrowed this cable for the I/O circuit where I was doing some temporary digital to analog conversion. It should go in there with ground in the middle. It's my little speaker. It's worth remembering that I'm currently connecting up the clock chip, which is the same as the crystal on the UART, and my long-term plan is to have the PCBs for the audio mounted on the same back plane as the UART so they can share the clock signal there, so I've only got one of these crystals on the board. Let's power this up and check I've done this correctly. I love the way the LED volumes show like this. Okay, I'm really pleased that actually still works. Now the circuit here is actually quite simple. It's just the 6 chips plus the crystal. So I think this is going to be fairly easy to convert. Let's take a look at the schematic. Okay, so at the end of the breadboard build, this is the circuit we had. Got the analog parts separate. Now, the 3 to 8 line decoder, we're only using 4 of those data load lines. We'll get rid of those. We also took 4 bits across, which would give us 16 data loads, which would need a second decoder for the high 8. And since we're not using more than 4 of them, let's simplify the circuit there a bit. When we built this circuit, we mixed the 4 channels together. We buffered it through this op amp in order to create the output. But we've got 2 op amps on this chip. I'm just going to independently drive those to give us separately driven left and right output. This is a 3.5mm headphone style jack. I believe I identified those correctly when I placed it. Don't need those there. Okay, now this circuit's actually pretty simple. We've got 5 chips on the digital side and 1 on the analog side. Now this is the developing backplane that we've got the peripherals on. So at the top here we've got the UART serial port, is the 2 synthesizer channels, and then down here is the space that we've got to put the audio controller in. Now I'd like to fit it into as small a space as possible here. We're running short of space. Should never have let people talk me into 4 channels. Now this is interesting, of course. The low 8 bits comes from the audio bus, but the upper 8 bits don't. They come direct from the main bus. So that's the width. Height, we just want it to be as small as possible. I think we want that to hang off the right hand edge. Would be really obvious to put those adjacent to one another like that. That's not right. I've made an awful lot of circuits where things like passives, where I haven't specified the correct values on the schematic. I'm trying to be more precise about that. It's okay assuming I'll remember it, but a few people have been looking at these PCB designs and I don't want to cause anyone any trouble. I only need the load line, not the assert. I've actually got duplicate copies of these. Okay, where did that go? Not needed. I mean, that reset comes from Y3, so we actually would only need 2 of these lines. Don't actually need these bus lines connected, but leave it there for completeness. We do have to be careful in this step. This is complaining about everything we've not connected up, and I'm marking them as not needed, but you need to do that as not an automatic click. Otherwise you might make mistakes. Reorder those a bit better. These don't seem to be rendering correctly. I'm not sure why. That's quite small. Now actually, if we've got the 3.5mm jack on the right hand side here, we're going to run into a problem with the bus connector, but we can just reorder these PCBs if we need to. I could probably make this all a square shorter, but it's going to start feeling very cramped. Right, it's a fairly simple circuit. Let's route it. Now I'm going to hide ground and VCC, which makes it a lot easier to route the other connections. Interesting reminder that this section is very isolated from the rest of the circuit. Doing this as a long thin board is not the best way. It's not a problem for me here, but on a more complicated board it would be a real pain. So looking back at this, if I'm going to stick the audio jack on the right, it can't go there because I'll be blocked by a possible interconnect. I could move it up to the top here, but I could do a PCB on its side. Put the jack at the bottom, but we know I want the controller and something for storage. And putting 3 PCBs along here vertically might be a bit easier. There's definitely wiring on this one that would suit better going vertically. I'm going to try that. Now, I'm thinking if I put the bus lines vertically here, it's going to be really easy to connect up. Obviously we can make this a lot narrower. Okay, so I'm adding these ground pins at the bottom just to provide stability and rigidity. I wanted these outputs up high so I don't have to route them past the lower lines on the back plane. Probably not that much difference, but it will be easier. Be easier if those were like that though. I think this is going to be a lot easier. I think we've made a mistake there and we've got one more square. That's going to be really cool. Right, let's try routing this version. Well, that was easy. So that's the mixed audio, and I do want to be careful about what I route it near, just to avoid interference. Okay, I'm going to get these lines a bit closer together. Going to want a good ground connection. Now, one of the great things about this alternate orientation for the board is it's all inside the 10 centimeter by 10 centimeter threshold where my current PCB supplier gets a bit cheaper. Right, let's make this a 4 layer. I seem to make that mistake every time. Alright, so we'll try and get them to stick the ID in there. It's definitely the right thing to do. Far better than the other arrangement at least. Okay, now that bit's not going to line up very nicely with doing a hookup with the breadboard, so I'm going to create a little temporary stub plane. Okay, let's take a look at this thing. Got the stencil. Okay, this is a very, very compact PCB. The moment I got this out, I started to fear that maybe the solder paste was a bit old. Alright, this looks pretty good so far. I do feel like every time I do this, my hands get slightly less steady. That was of course the one part that I didn't have in stock. This is annoying. Okay, no, it does fit. Okay, so I'm going to deal with this next step by putting all of the headers onto here. Maybe you should have done this step before I put the audio connector on. Easy to realise that in hindsight. Now it'd be great to avoid little stub boards for holding things together like this, but I'd rather actually just have a build that worked without having to go to extreme measures to avoid such things. Okay, that should drop in very easily. It's not going to be very easy to test this off of the main build, so I'm going to have a bit of a clear up and we'll get the main system out and see if it works. Hopefully have a very short test video. Okay, well, just looking at this does give you a nice little reminder about the amount of size reduction we can achieve when we convert stuff to PCB. We're going to need to move some of this stuff around. Okay, so this is the low half of the audio bus. It's there. That's main bus, which we were just daisy chaining off there. I think we're going to need a longer wire for that. That can just connect directly into there. And main bus goes there. There's the channel outputs. Doesn't actually matter which way round I do them, I'll just reverse the numbering of the channels. There's a spare ground line in here which I'm not currently connecting. This is device 9. Just have to make sure that's the right way round. Actually, that's the load lines. That's the mix outputs. Actually there. Need to worry about that and the power. Right, just swapping a shorter cable in there. Right, so clock and power I need to worry about now. This has power from here. Right, I think that's all the connections, apart from the most important one. Right, let's power it on and see if it works. Right, this is promising, or is it? Right, I was thinking that didn't look right because the volumes are not all at 0. Felt like an awful lot of stuff was doing the right thing. Right, so to zero a channel at the point of the load, we've got the top 4 bits high. Not mean to do that. Okay, so I'm getting the bus tester out here. Now I should be able to load the data that's on the bus into this set of LEDs by triggering this line. So if I disconnect those, put that into channel 0. At the point where that line changes, we should have the high bits on the main bus. which is what we've got. This cable comes out wrong. And finally they've all reset properly. And attempt 2. So all of the volumes seem to be changing correctly, but the clock, I've got the output in the wrong place, so it wasn't receiving a clock signal. Fabulous, that works. Slight little problem there. It was just this cable was dodgy. I will have to check that through, but I can see the plastic's broken here that I didn't notice before. Maybe been trodden on or something. Okay, I am incredibly pleased with this. I was worried for a bit that I'd left it a bit long between building the breadboard circuit and finalising the schematic, that maybe I'd forgotten something important, which would have caused me a problem. But apart from a couple of things where we had some wiring problems and got a component slightly wrong, it just worked first time as designed. So very pleased with that. This is the audio circuit essentially finished. I will probably be doing one more video in this. I definitely want to explore what can be done with this sound device. That might take the form of just some larger demos that incorporate more systems, or it might be just another video in this series in addition to the audio work I put into some of the games and demos I'm going to develop for the completed system when I'm done. I'll be touching on this stuff a little bit when I design a big backplane for the I/O subsystem, and of course then we'll get rid of this little breadboard where we're currently needing to have the clock crystal live, because we'll be able to wire it directly from the UART at that point, and then it will all be completely finished. Big thanks to everyone who continues to support me on Patreon. I really do appreciate it. Thanks all for watching, and I will see you again soon. Goodbye.